Hey guys, welcome back to the shop. My name is Doug. It's Metalworks Machine Shop, and we're going to build a fabrication welding table today. I know y'all seen a lot of tables being built and a lot of high dollar ones, people trying to sell their product, which is all well and good. I think these so-called precision flat tables is the dumbest thing in the world for a fabricator. Show me one fab shop that does high production that has one of these. I think it's absolutely crazy what they cost. You could find acorn tables cheaper than what these things are going for. I almost bought an acorn table. Was going to pay about $4,000 for it, and it was just a 5x5, and then it had a piece of 1/4-inch plate on top of it. But then, you know what acorn tables are for? They're for jigs and stuff like that. And it was nowhere near flat. I checked that. It probably had 3/16 gap between it. The straight piece of metal going across it. It was sagged in the middle. But I read comments about people wanting, get the high grade or tested metal or good metal. You can get graded metal, certified they call it. They guarantee it to be X amount of thickness, and like you can get square tubing and angle that's certified. We built towers and stuff like that to where all the tubing had to be certified, which is guaranteed that it's not thin in the break or the bend of the tube. So, but anyways, yeah, this is all scrapyard material. I found it local scrapyard. It's almost a 5x5 piece of 3/4 inch. There's a piece of 3/8 and some 6x15 beam. 6x15 means it's a 6-inch, 15 pounds per foot. So, and I'm going to make this thing flat-ish enough. It doesn't need to be 30 thousandths like people claim their tables are, or less. I think that's nuts. I think that's a table, that's a trophy table that no one is going to use. Every shop would love to have one, but you'd be afraid to use it because you're going to scratch it, ding it, drop something on it. I think it's just crazy. A true fabricator will work off of anything. I work off the floor. I do the 3-point thing. That's been around. I've known that for years, when putting something together. But I'm up in my 50s now, and getting down up and off my knees hurts. So that, and I need a table to clean material up from my burn table. I want to make this table the same height. It's going to be on casters. Like I said, I got this at the scrapyard. Got 1,800 pounds. I got some pieces of channel out there, and some 2x2 square tubing, and some 1.5 by 2 inch angle iron. So, come out to about 1,800 pounds, and about 18 or 19 cents a pound is what I paid for it. And yeah, let's build us a usable table. Alright, and that'll be flat-ish. Alright, I'll bring you back. Okay, I got all the brackets and clips and stuff like that drawn up into CAD. Then I had to measure the plate that I have in order to lay everything out on it. And I've already ran 2 test runs on it to make sure I stay within the size of the sheet, because it is nowhere near square. So it's So I got all the tool paths and everything, all the holes. It should cut all the holes first, and then hopefully it'll go up this row here, and then back down this one, and then up this one, and then end up with that one. I don't want it cutting a few out of the middle, and then it warps the sheet, and then it won't grab these out here. So I put it all into layers. So this out here's layer 1, 2, 3, and 4. Actually 2, 3, 4, and 5, and the first layer is all the holes. See how the piece of 3/8 plate that I have. So everything is gonna be cut out of this strip here and a little bit off, because when I laid it out, I had a piece that caught about a little bit of this hole, so I had to move it up there and reshot it again, and all's good. All right, we'll hit the start, see what happens. Looking through your glasses. Alright, I got all these done. I did run a drill bit through them. They were tapered a little bit. They fit, you know, the bolt didn't want to go through. But I just ran, these are all 5/8 here. 5/8, 5/8, 1/2 inch. And these are 3/8. These are for the casters. Yeah, going one way. So, and the casters are 600 pound a piece. I like to find some heavier ones, but some things cost a lot of money. Those are just the Harbor Freight, the heaviest ones I have. I had one screw up somehow. It was in the program. It made on the offsets. It's supposed to be just like this one, but it cut the lead in and lead out was on the outside of the hole, and it cut the outside of the hole, and it also cut the inside of the outside. So it's, I mean, the holes, everything's fine, but just a little smaller, narrower. These are for the 2x2 square tubing to bolt to the I-beam or the beam. I might make that up, I don't know. I mean, it kind of bothers me a little bit, but it'll work just fine. And it'll be down at the bottom and you'll never see it, but I'll know it's there. Alright, I got everything cut, and the angle irons, I got the holes drilled in them for the X-brace, and I have a jig built up so I can weld the end plates onto the tubes. And this is what I do all the time when I worked in a fab shop. You know, you always had the grunt or the new guy cutting and putting holes in the parts, and then once he had enough parts, I'd start making jigs. So yeah, we go. So old Chinesium 1, 2, 3 blocks, got them clamped down. Piece of angle iron, it's true 90-ish. I mean, it's close enough. Use it, you know, I did use a Starrett square. You know, I got that 90 with the block with the same gap between them. Got it sitting on a set of blocks to get my spacing. And these blocks are just a little over a 1/16 too high to be perfect center of these plates, but that's close enough. And basically the same thing over here. That's what I did all the time, and it takes a minute. takes a hot minute, you know, to get one set up and get it done. But like if you have 20, 30, or 50 of these to build, you're gonna be glad that you took an hour, 2 hours to build a jig. I mean, I did a lot of parts all the time, just not every day. So we build jigs like this, only a lot beefier. You know, this is sitting on a piece of 3/4 inch plate. You know, we'd use like big pieces of I-beam and make jigs for stuff, for big posts and stuff that we would build. And we knew that we had different sizes already made up, to where we just go out there and in the yard and dig out the jig and bring it in, and then set one up, check everything, make sure nothing got bent or tweaked, and then you go to town with it. You know, knock out several of these a day instead of trying to center these up like I see so many videos, guys just setting them on there on the flat on the floor, turning it up. I mean, you can see the gap here to there, you know, but I am perfectly square from corner to corner on the plate, and I'm to my length. 44 3/4, right on it. I mean, it's on. I can't. I got the C-clamps in the way. Boy, this is terrible trying to hold a camera and. Get that out there and right on it. I mean, this thing's perfectly square. Not saying it ain't gonna move. That's why you gotta tack, 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 let it cool, let it cool, let it cool. I can't, you know, that's the only thing that's gonna, because as soon as you put one tack on it, it's gonna pull. So like, you see the gap up the side there and then across, and it's touching here. So wherever it's touching is where my first tacks will go, because if I put a tack there, it's gonna suck that in so tight. You know, it won't be perfectly square, but that's less. That's probably not even a 30-second gap, but still, when you're counting on your cross members and X bracing to make this table square, yeah, you take a little time and get a little picky on the fabrication side, because I want this thing to come apart, be able to take it apart. Like if I ever moved or whatever, or sold it, you know, I don't have this 1,000-pound table that nobody can load, or they won't be able to unload it. You know, the heaviest thing on this will be the top, and it's all going to be bolt together. And if it was real critical and it's a piece this small to where you can't let anything, where you don't give anything time to really cool, I'll have a bucket of water and a soaked and wet rag, and I'll lay on the part, lay the rag on there like a shop rag, and then the water will, you know, it'll keep the metal cool. And you know, when I'm done, then I'll shove the rag up against the weld and let it steam, let it cool it down. But yeah, let's see how much of a pain in the butt this is going to be to pull out and not move anything. Oh, yeah. Woo. Yeah, a little bit at a time. Lucky bag. That went right in. A little looser pulling out than putting back in, so That taper in 4.5 inches can't be much. And the tube is 1/8 inch. So if I got it that hot to cherry that side of the plate, that's damn good penetration. A hard wire with compressed gas is not structural. It's actually the weakest weld there is. I've done a lot of this. We built a structure once and hired a welder, well, a so-called welder, and he wound up MIGging most of the structure of it instead of using flux core with gas. That's the ticket right there. That's what you need to use for anything structural, or 7018 arc. But yeah, this, it picked it up and it bowed, with the crane, with the whole structure. Once we bolted it, we put it together on the ground and used a crane to lift it up. As soon as the crane started lifting, you could hear the welds popping. There's one. Yeah, and I made a bunch of blocks over the years. I don't even know where half of them are anymore. And these here I got off of an old machine when I was rigging machines for General Motors.